Wireless LAN modulation techniques. In this video, we are going to see what is modulation and its types, that is analog and digital modulation. What is modulation? Modulation is the process of varying one or more properties of a periodic waveform called the carrier signal with a modulating signal that typically contains information to be transmitted. That is, when you transmit an information while transmitting a message, that information will be modulated. We call it as the carrier, the message signal or modulating signal, and it is the modulating signal will be carried by a carrier signal whose properties will be changed according to the modulating signal. That is modulation. And most radio systems in 20th century used frequency modulation or amplitude modulation for radio broadcast. A modulator is a device that performs modulation, and a demodulator is a device that performs demodulation. That is the inverse of modulation. A modem can perform both operations because it has both modulator and demodulator built in it. Wireless LAN modulation techniques. Wireless networks use modulation techniques to send data. It enables the sending of encoded data using radio signals. Modulation could be of two types, analog or digital. So this figure shows the types of modulations. As I have said already, there are two types of modulation, analog and digital. Again, analog modulation can be amplitude modulation, frequency modulation or phase modulation. And digital modulation is based on keying, and the three different types of digital modulation are amplitude shift keying, frequency shift keying and phase shift keying. We're going to see some of the words which we use in this modulation video. They are baseband signal. Baseband signal means the signal which carries the information or which contains the message. And passband or bandpass signal means it is the carrier signal which is going to carry our message from sender to receiver. Amplitude. Amplitude of a wave means it is the height of the wave. Frequency represents the number of waves that pass by each second. And the phase involves the relationship between the position of the amplitude crest and troughs of two waveforms. And phase can be measured in distance, time or degree. Next, we will see what is analog and digital modulation. The aim of analog modulation is to transfer an analog baseband signal over an analog bandpass channel. Example, when we transmit a TV signal over a cable TV network channel. The aim of digital modulation is to transfer a digital bit stream over an analog communication channel. This is what we see in the telephone network. Analog and digital modulation facilitate frequency division multiplexing or FDM, where several low pass information signals are transferred simultaneously over the same shared physical medium using separate pass band channels. So now we know what is analog modulation, and there are three properties of a carrier signal: amplitude, frequency and phase. Thus there are three basic types of analog modulations. They are amplitude modulation, frequency modulation and phase modulation. Amplitude modulation. In this figure you can see the first signal is the information signal, otherwise called as the modulating signal, and the second wave is the carrier signal. Now, based on the information signal, the carrier signal, the amplitude of the carrier signal is changed in accordance with the information signal. And finally, we obtain a signal which is the amplitude modulated signal. In frequency modulation, in this figure we can see three different signals. The first one is the modulating signal or the message signal. Second one is the carrier waveform. The frequency of the carrier waveform is changed in accordance with our message signal or the modulating signal, and finally we obtain a frequency modulated signal. In phase modulation, the phase of the carrier signal is changed according to the message signal. So finally we obtain a phase modulated signal. In that we can see the change in the phases, change in the directions or the degrees of the signal as per the modulating signal. Next is digital modulation. It is a technique that uses discrete signals, that is zeros and ones, to modulate a carrier wave. In digital modulation, an analog carrier signal is modulated by a discrete signal. Digital modulation methods can be considered as digital to analog conversion, and the corresponding demodulation or detection as analog to digital conversion. In digital modulation, we can see the concept of keying. Keying is a family of modulation forms where the modulating signal takes one of a specific number of values at all times. The goal of keying is to transmit a digital signal over an analog channel. The three main types of digital modulation based on keying are amplitude shift keying, frequency shift keying, and phase shift keying. In amplitude shift keying, the strength of the carrier waveform is altered to denote binary numbers 0 or 1. Here the frequency and phase of the carrier signal remains constant, and ASK is highly susceptible to noise interference. In frequency shift keying, the frequency of the carrier signal is varied to represent the binary digits 0 or 1. Here the amplitude and phase of the carrier signal remains same, and FSK removes most of the noise problems. In phase shift keying, phase of the carrier signal is altered to represent the binary 0 or 1. Amplitude and frequency of the carrier signal remains constant in PSK. So this is a figure which shows ASK, FSK and PSK all together. So we can see the first one, first signal is the digital signal, that is the actual message which contains 1010. So we are going to send 1010. We are going to modulate these signals. So the second wave is the carrier signal. We are going to modulate the digital signal using the carrier signal. Okay, so the first method is ASK. In that, ones are represented using high amplitudes and zeros by very low amplitude, which is almost equal to 0. In FSK, we can see the change in frequencies. So the ones are represented using high frequency waves and zeros are represented using low frequency waves. And in phase shift keying, we can see there is a change in the degree, change in the, we can see a shift in the phase when it change from 1 to 0 and 0 to 1. This is how digital modulation is done. I hope you all understood what is modulation and its different types. Thank you.